Hey class, so we're going to go over lesson 2 today, which is compounding interest. So we already talked about simple interest. Compounding interest is interest that is compounded at a regular interval. So we'll talk about what that means and how it might be better or worse to invest in a compounding interest account than a simple interest account. Compounding interest is often the type of interest that they use when they give out loans, as well as credit cards use compounding interest. So we'll be talking about credit cards 2 lessons from now. So what we're going to be doing is at the end of this lesson, you will be able to calculate the number of times interest is compounded, which is n, which is also called the compounding interval. You'll be able to convert to an adjusted annual interest rate in decimal form using I, depending on the compounding periods. You'll be able to do substitution into the formula A equals P 1 plus IN, right? So we're going to be finding I and N and how to find those. You'll be able to understand various compounding periods. You'll be able to recognize the value of P and its use in the formula A equals P 1 plus I to the power of N. And you'll be able to determine the different types of investments that might work for you. Compounding interest is interest that occurs when interest is added to the principal at the end of the compounding period and it's included in further calculations. So with simple interest, right, you only got compounded on the initial amount. You only got interest on the initial amount that you put in. So say 5 years ago you put in $200, you would only get interest on that $200. Whereas with compounded interest, when you made $10 at the end of the first year, they reinvested your principal, and now your principal was 210, and then 220, and then 240, so on and so forth. Okay, and we'll talk about how we can calculate that. So basically, compounding interest is almost better because it just reinvests your money every time. More often than not, compounding interest, if you are getting a compounding interest account, usually has a lower interest rate just because you're getting it compounded. So we're gonna see which ones might work better for you. Compound interest, we're going to see this is an exponential function, whereas simple interest is a linear function. So Jonas decides that he would like to deposit $1,000 into a saving account for 4 years. His bank is giving him 2 investment opportunities. So the first one is 5% per year simple interest. And option B is pay 5% per year, and that's compounded annually. Right? So compounded annually just means that every year, once his interest has gone in, he will get, they will reinvest that and the interest will be calculated on that now new number. So how much interest would Jonas earn in each option and which one should he choose? Explain using the table and the graph. So let's start off with our compound interest right here, right? Or simple interest. This is stuff we just did yesterday. So I'm just going to go back and we're going to go over how to do simple interest calculations. And this is super easy stuff. This is just from yesterday. Nothing new here. Same thing. Okay, so we have our starting balance. So we're going to be using interest is equal to PRT, right? Which is what we learned yesterday or in our last lesson. So the balance that the interest is put on, our principal starting balance is $1,000. So that's going to be our P value, right? So if that's going to be our P value, we're going to go in and say, okay, I is equal to PRT. So I is equal to 1,000. The interest rate is 0.05, just that's 5%, and the time is going to be 1 year. If I do all those calculations, I know I'm going to have $50 in interest. So my ending balance will be 1,000, which is how much I originally put in, plus plus 50, which is how much my interest was. So it's going to be 1050. Right? Easy peasy. That makes sense. You start off with a certain amount, right? You find the interest in 1 year, and then you just add those two together, which is what we learned with simple interest last class. Okay? So let's see how much we can find in 2 years. So I would ask that actually you go back and try doing this by yourself, right? You know how to do them. Try to find out how much it is each time, and then we can go back and compare them. So hopefully you've paused and you've tried again. So again here, because it's simple interest, right? Your starting balance after 2 years is going to be $10.50, but you're still only being charged interest, or you're still only getting interest on that first initial $1,000 that you put in. So let's go put that in, PRT. Again, it's 1,000 times 0.05, and it's still only 1 year, right? You're still only adding one extra year, so it's $50. So now you can do, or even honestly, you could have done this. Said 2, it's 100 now, right? And you're just going to add to your principal, which is 1,000 plus 100, which is going to give us $1,100. So your balance at 3 years is $1,100. You're still only getting interest on that original 1,000, right? The interest now is going to be 1,000 times 0.05 times 3, which is going to give me 150, right? So then I'm going to do 1,000 plus 150 is equal to $1,150, right? 1,000, you're still getting taxed on the same amount, so you're going to do that. 1,000, 0.05 times 4, right? And that should be 200. So you know that you're going to have 1,000, this would be 1,000. 1,000 plus 200, you're going to have $1,200 as your ending balance. So after 4 years, you will have $1,200, right? So if you want to know how much interest you made, equals 1,200 minus 1,000 equals $200 total in interest, which you could have just found from here. You're going up by $50 each year. Okay? So that is how you're going to do it with simple interest. Now let's go to compounding interest. And this one's the one that's a little bit more complicated, and it's for a good reason. Okay? So let's go look at how much our balance is being charged on this year. So you start off with $1,000, so the balance is being calculated on $1,000. So let's do I equals PRT. Same thing. I is equal to your principal, which is 1,000, times the rate, which is 0.05, times the time, which is 1 year, right? And that's going to be $50. Now, instead of, charging it back on that 1,000 you had originally invested, what the bank does now, it just reinvests your new balance. So instead of being calculated on the 1,000, you're calculated on the 1,050 now, right? So now your interest is going to be I equals P, and your new principal is going to be 1050. Your interest rate stays the same, so it's 0.5. And your year instead of 2 is going to be 1 because they reinvested it. So it's going to be just 1 year on this new principal balance. So now it's going to be 1050 times 0.05 times 1. So instead of making just $50, you're making $52.50 in interest, right? So I'm going to do 1050 plus $52.50. So my new ending balance is is going to be 1050 plus 52.50. It's going to be 1102.50. Notice how it's already more than it was here, right? Because here it was 1,100 and now it's 1102, and I know it's only $2.50, but it's already more. So now we're going to take this 1102.50, 1102.50. That's what our new interest is going to be calculated on. right? So now we're going to do I is equal to 110250 multiplied by 0.05, and it's still only 1 year because you reinvested it. And you should get 55.13. Notice how now there's more money being invested, right? So now you're going to do 1102.50 because that's your new principal plus 55.13, and you're going to have 1157.63. Last but not least, we're going to take that 1157.63 and we're going to invest it again into the same account at the same interest. $57.88. Now we're going to do 1157.63 plus 57.88, and I'm going to get 1215.51. So now my new interest here is going to be, I originally invested, I still only put in the same amount. Interest is equal to my final amount, which was 1215.51, minus, I still only put in $1,000, but I'm still left with 215.51, which is $15.51 more than if I had invested in the other option, right? Because for the same money, I just made more overall. Okay, so that's how compounding interest works. So I made a graph for this already. I won't have you graph it out yourself. I'll just put the graph in and show you what it looks like, just because it's easier for me to show you. So let's go down here, just going to put the graph in. I'm going to make it a little bit smaller so that everybody can see it. So I made this graph and I compared the two. So I just want to zoom into this graph and talk about it for a minute. So notice how with option A, which is your simple interest account, you're kind of consistently going up by 50 each year. So you're just going up in a straight line, right? So option A is a very safe choice. It's going to go up same amount every year. You know you're going to make $50 every year, right? Whereas option B here starts off about the same, so there's not that big of a difference. Like you were like, okay, missing. It's only like $5, $15 more. But as you go up and up, it starts to become an exponential function. So it'll start to grow away from this straight line, and then the gap will become bigger and bigger, right? And that's what's important here, is that the potential for a compounding interest account is way more just because it is an exponential function. So while at the beginning the difference kind of seems like the same, when you move on and you've left that compounding interest account just alone for 10, 15, 20, 60 years even, you'll make way more money, right? So it's in Jonas's best interest to choose option B because he'll just earn more interest. And while it's only $15 in the first couple of years, eventually it'll be more than $15. So I would say, therefore, Jonas should pick option B because he'll earn more interest. And like obviously, even if it's $15 more, you're gonna want that one for the same amount of money. Why would you not? So like I said, simple interest is linear growth. At the rate of change, the interest is being added to the principal, right? The rate of change is just the $50 in the situation, or the amount of interest on the principal. And because the principal is always the same, the amount will always be the same. The amount will always be the same. So if you're investing $1,000, you're always going to get $50. If you invested $2,000, you'd always go up by $100. Whereas compound interest is exponential growth. As the money grows, it's multiplied by the growth factor 1 plus I, which is your interest rate. And we're going to talk about different compounding periods because different compounding periods might actually affect how much I grows at. Okay? So we're going to talk about what the compounding period is. We're also going to talk briefly about what affects compounding period. So, interest is commonly compounded or calculated at regular intervals. These intervals can vary. Below is a list of commonly used intervals and the number of times per year interest is earned on interest as calculated. So, if you're getting something that's compounded annually, right, it means there's only one compounding period. It means that at the end of the year, they take the amount you have left, add interest to it, you reinvest it. It's just one. So one compounding period, you leave the interest the same, and N is the number of years. So say you leave something in your account for 6 years, compounded annually, N will be 6, and I will be whatever the interest is. Annually is pretty easy. Semi-annually means that halfway through the year, what they will do is they will take whatever amount of money you have in there, right, reinvest it, and then you'll get it will be compounded 2 times in that year. So they'll take it halfway through the year, give you the interest, reinvest that interest, and then do it at the end of the year. So now you have 2 compounding periods. In this situation, the interest rate is divided in 2, and then N is going to be the number of years times 2. That's because you've done it 2 times in a year. So if you were doing this for 6 years, it will have reinvested itself 12 times, because 2 times per year for 6 years, that is how many times it reinvested itself. Quarterly is 4 times a year, so you have 4 compounding periods. That means that, and it's usually done, there's quarterly, when you go and look at, like you'll hear quarters, when you talk about when certain companies need to make their deadlines, right? Quarterly means that at the financial year, it's usually split into 4 quadrants, right? At the end of the quarter, you're going to reinvest that stock, or you're going to reinvest whatever you were investing in, right? That means that in the year, you reinvest the same stock 4 times, right? So the interest rate is going to be divided by 4 because that interest rate needs to be split amongst those 4 compounding periods. And then N is going to be 4 times the number of years because you pulled it out 4 times, you reinvested it 4 times. Okay. Bi-monthly means every 2 years. So you have 6 compounding periods. So you divide it by 6 and you multiply the number of years by 6. So monthly means that you've done it every month. There's 12 months in a year, so there's 12 compounding periods. Interest rate means that you divide whatever the annual interest rate is by 12 to get the monthly interest rate. And then you take however long you've left that there and multiply it by 2. Most credit cards use monthly, right? Because you pay your credit card bill at the end of the month. Then you have semi-monthly, which is 2 times a month. Then you have bi-weekly, which is every 2 weeks. This is, just be careful with this. They're 2 different numbers, and even though theoretically it should be, semi-monthly should be halfway through the month, there are 2 different compounding periods, so just be careful with that. Weekly means that you will reinvest it once a week, and daily is every day you reinvest it. You can simply just print this chart and keep it for yourself, right? Really easy. It's all there for you. It's laid out how interest rate works, how compounding periods are calculated. Okay? All right. So to calculate the compounding interest, you are going to use this formula. It's called A equals P 1 plus I to the power of N. A in this situation represents our final value, right, after however many compounding periods. P represents the principal, which is how much we originally invested. I represents the I up here, the interest rate in that compounding period. And N represents the number of compounding periods. Okay? So the values P, I, and N must be substituted into the above formula to find A, which represents the amount of compound interest that has been made in addition to the initial investment or loan, right? Or the total amount of money made. When you're calculating the value of N in the formula, N represents the total number of compounding periods over the entire loan or investment, right? So say I invested something for 10 years, I compounded it monthly. That means that the number of compounding periods I had per year was 12, right? Multiplied by the number of years. You can also just go back up here and use this and be like, okay, if I have something compounded monthly, you can just go and look, okay, monthly, that means I need to multiply the number of years by 12 in order to get my N, right? So you can use this chart. It will be available to you during an assessment. So let's find this. So it says, what's the value of N if the loan is compounded monthly for 3 years? So if I know something is being compounded monthly, I know that I'm going to take number of compounding periods a month is going to be is going to be 12 because there are 12 months in the year, right? And the number of years is just 3. So I'm going to write N is equal to 12 times 3, right? So 12 times 3. In this situation, my N value is 36. Okay. If you move on, it says, what's the value of N if a loan is compounded quarterly for 5 years, right? So if I go back and I look at my chart, I'm going to go here and be like, okay, quarterly N is equal to number of years times 4, right? So let's go here and write N is equal to number of years times 4. N is equal to 5 years times 4 is 20, right? So it's really easy. You just need to look at that chart or think to yourself, if something's compounded quarterly, it means it must be reinvested 4 times that year. So I know it's going to be 4 times 5. Okay. The opposite is true for I. I means that it's the entire year's interest loan, right? It's the entire annual interest rate. So how you're going to find I is you're going to take the annual interest rate and divide it by 100 to get a decimal, and then divide that by the number of compounding periods per year. So if I have an annual investment rate if I have an annual interest rate of 10%, right, and I'm compounding that bi-monthly, right, I'm going to go back and be like, okay, I have an annual interest rate of 10% and I'm compounding that bi-monthly. It means that I'm going to take my interest rate right here, divide it by 6 to get I. So let's see. Let's do a couple of questions. So what's the value of I with an interest rate that is compounded, a rate of 12 compounded quarterly? So our interest rate is going to be I is equal to 12. Or so I'm going to write the equation back down. So it's going to be the annual interest rate. So it's usually written as APR divided by 100, right? Divided by number of compounds per year. So my APR, or my annual interest rate, is going to be 12%. Divide that by 100. And the number of compound periods per year is 4. So it's going to be I equals 0.12. Divide that by 4, right? And I should get 0.03. If you had gone back up here to your chart, you could have seen, okay, it's compounded quarterly. So I know I just need to take the interest rate and divide it by 4. And you could have done it that way as well, instead of having to write it out. So this says semi-annually at 8%. Let's find rate in decimal form. 8% goes to 0.08, right? And it says semi-annually. So let's go back up to our chart and find semi-annually. And I know semi-annually means twice a year, which means I'm going to take the interest rate and divide it by 2. Equals 0.08 divided by 2, which is going to give me 0.04. So that's how much my I is going to be. So I'm going to have you work through these ones by yourself, right? Work through them by yourself and then just come back here and I'll answer them for you. But I want you to try them on your own first. Use the chart. The chart is there to help you. I would even recommend having it printed out and kept on the side somewhere as you work through these problems because it'll be super, super helpful for you. All right. So hopefully you pause the video and you work through it yourself. So this says an interest rate of 11% compounded annually, right? So I know my rate is going to be 11%, right? It's compounded annually. So I'm going to change it to 0.11. If I go back and I look at my chart up here, I know that the compounding period annually is just 1, right? So it's just going to be whatever interest was given. So I know my interest rate is just going to be I, which in this case is 11. Therefore, I is going to equal 0.11. An annual interest rate of 24% compounded semi-monthly. So when I go back to my chart and I look up semi-monthly, it says that means twice a month. That means that I'm going to take the interest rate and divide it by 24. So let's find what the interest rate is. 24%. We're going to change that to 0.24, right? And then I equals 0.24 divided by, and it says 24. So let's do that. I equals 0.01. So my interest rate in this situation is 0.01 per semi-monthly compounding period. Okay, and then an interest rate of 16% compounded quarterly. My rate is equal to 0.16. My I, if I go back and look at it, I is equal to rate divided by 4. So it's going to be 16. So 0.16 divided by 4, which is equal to 0.16 divided by 4 is equal to 0.04. And that's going to be my I value. So now that we know how to find I and N, right, we need to find how to find P as well. So now we know how to find I, we know how to find, we know how to find I, we know how to find N, we just want to know how to find P now. So let's go think about it. P represents the initial amount, just a principal amount. So when I tell you that $500 was borrowed at an interest rate of 7% compounded daily, it's the same thing as our last one. Our P value here is going to be $500, right? So let's do a little bit of practice with this. So it says find the P value for each of the situations described below. A $2,000 loan at an interest rate of 5% compounded weekly, right? That's going to be $2,000 is going to be your principal amount there. You have an interest rate of 7% compounded daily on an investment of $5,000. You originally put in $5,000, so your interest rate, your P is going to be $5,000. And with this one, as you can guess, it's going to be 100, right? You just go and look at how much are you originally putting into your loan or whatever it is that you're doing. So now that we know how to find P, we know how to find I, and we know how to find N, we know how to find all the values in that equation except A. So when you're looking for A, what A really is just the amount of, it's just the final amount. Same thing as your last simple interest one. You take the principal and then you add the interest that you earned on it. So A is equal to principal plus interest, right? Which in this case, our principal amount was, says for example, $5,000 was invested and $200 was made in interest, right? We're going to take our principal amount, which in this situation was just $5,000, right? And then we're going to go and add to it 200. So we're going to go 5,000, right, which was our principal, and then our interest earned was 200. So 5,000 plus 200 is just 5,200, and that's what our A value is. It's just our final amount. Okay? So now let's take everything we've learned and put it all together so that we can find what our interest plus our principal value is, right? So let's go and make this so that we can find what our final amount is going to be. And let's also compare this, right? Let's compare this to simple interest. So we're going to do both. So let's find it with compounding interest. So I know that the formula for compounding interest is A is equal to P 1 plus I to the power of N, right? So I know I'm going to need to find my P, I know I'm going to need to find my I, and I know I'm going to need to find my N, right? It's just easier if you have this all laid out for you. So let's go see what the initial investment was. So our initial investment was Johnny invests $800 to pay, that pays 8% compounded quarterly for 5 years. So let's start with our principal. Our principal is $800. He put in $800 into his account. It pays 8% compounded quarterly. So let's go find, and let's just go back up to our original little chart that we have here. And if we have something that's compounded quarterly, I is going to give us divided by 4, and N is going to be the number of years times 4, right? So let's go back and use that values here. So I is going to be interest rate or annual interest rate, which is just APR divided by 4. Right, and number of N is going to be years times 4. Right, so one's going to be divided by 4, one's going to be times 4. So let's go calculate our interest first. So I'm going to put interest in this green. Right, interest is equal to our annual interest rate is 0.08 because it's 8% divided by 4 because it's over 4 compounding periods. So 0.08 divided by 4 is going to give us 0.02. And I'm going to do N in this pink color. Our N is equal to number of years multiplied by 4. And that's just straight from the chart. So our number of years, he says that he's going to invest this. He wants to know how much it is of the 5th year. So it's going to be 5 times 4, which is going to give us 20. Now I have P, I have N, and I have I, and I can just plug everything into the equation to find A. So A, I'm just going to come down here. So A is equal to $800. 1 plus 0.02 to the power of 20. Always do whatever's in the bracket first, so it's going to become 800. 1 plus 0.02 just becomes 102 to the power of 20. Then always do the exponent, so 102 to the power of 20 is going to give me 1.4859. 800 times 1.4859. Then I'm just going to multiply by 100. The same thing as last unit when you just did the exponent law stuff. So I'm going to be left with 1188.78. That means that on the $800, at the end of it, I'm going to have left over $1,188.78. Right? So therefore, the final amount after 5 years is. And that's going to be your answer. And then it says to compare that to simple interest. So let's say we had just done that at simple interest. Our simple interest future value is FV is equal to P1 plus RT. And I just recommend having like all these equations written out somewhere for yourself. I find it easier to just navigate that way. 1 plus whatever the annual interest rate was, which was 0.08, times the number of years, which was 5, right? So I'm left with 800. 0.08 times times 5 is going to give me 0.4. Add 1. 800 times 1.4. Times 800 is going to give me 1120. So if I was to put this in a simple savings account, I would only make 1120 a year, whereas with the compounded quarterly account, I made a little bit more because it reinvested, right? So 1120. Therefore, Johnny will make more money with the compounding interest. Which I guess we knew at some level, but that's just to prove it to you. Okay? So I want you to try doing example 2 on your own. It says that a $1,500 loan is taken out at a 12% compounded monthly for 3 years. So that's a lot of information right there, and that should tell you what to use in the chart. How much interest is added to the loan at the end of the 3 years if no payment has been made? So this is, you're actually taking out money and now you have to give the bank back money. So if you don't pay anything for 3 years, how much will you owe them back at the end of the 3rd year? Right, so let's go back here and say, okay, let's just go put out my formula. I know that this is a compounding interest, so it's going to be A equals P1 plus small I to the power of n. Right, I know that my P value is just going to be how much I originally took out, which was 1,500. Right, I know that I am compounding monthly for 3 years, so that means I is going to be something different and n is going to be something different. Right, let's go back up to our original little table here. It says compounding monthly, so it says that I interest rate is going to be interest rate divided by 12, and n is going to be number of years times 12. So I'm just going to go write that in. So I is going to be APR divided by 12, and n is going to be number of years times 12. I should say 12 there. So let's find our I. Our I is just 12%, which is going to be 0.12 divided by 12. Which is going to give us 0.01. That means that's the interest that's going to charge us monthly. And n is equal to number of years times 12, which is 3 times 12, which is going to give us 36. So now I can just go put in the different numbers into the original equation. So A is equal to 1,500, which is our P value, 1 plus 0.01 to the power of 36. Let's do what's inside the bracket first. 1 plus 0.01 is just going to be 1.01 to the power of 36. And so let's do that. 1.01 to the power of 36 gives us 1500 multiplied by 1.43. Let's do the multiplication now. My A is equal to 246.15. That means that the total amount I owe at the end of 3 years is $2,146.15, right? If I want to find out how much interest that is, interest is equal to A minus P, right? We just take however much we have to pay and subtract how much we originally had to pay, which is 1500, right? And that is going to give us $646.153. Therefore, $646.15 of interest was added. Which makes sense. If I lent you $1,500 and then you paid me back $2,146, you just want to find out how much extra you paid me, you just subtract the two. So why am I teaching all of this? Because you're like, Miss, like, why does this even matter? Because when you're making investments, right? When you're picking bank accounts, when you're picking savings account, you want to know which one will pay off, right? So you want to take into consideration, like, what type of interest is it? What type of compounding period is it? How long am I investing it for, right? And if it's a compounding account, how many times is it compounded? Because if it's compounded more, right, you're reinvesting more times, but then your interest rate is going down each time you're reinvesting it. So at what point does it not pay off to have it reinvested multiple times, right? So let's pick which one is a better investment. So here we have a simple tax-free savings account with the Royal Bank of Canada at 5% annually. Then we have a compounding interest tax-free savings account with TD Canada Trust that's compounded annually at 7%. And then last but not least, we have a compounding interest tax-free savings account with Bank of Montreal compounded monthly at 7%. And while option 2 and 3 might look like they're the same, we're going to see why they're not. Option 1, you can already tell it's a simple interest account. The rate of simple interest is significantly less as well. So it might not be worth it, but let's compare the two anyway. Okay, so I made this little T-chart for us to compare the two options. The first one is a simple interest account, so we're going to use a simple interest formula. So future value is equal to P1 plus RT, right? I want to go fill in what I already know. So I know the principal amount is the original amount that I'm investing, which is last year you made a surplus of $2,000 and now you're looking to invest. So we know that our principal amount that we're trying to invest is $2,000. That's going to be the same for all of them. You're only putting in 2,000 accounts, or the $2,000. You just want to see which one is the best for the $2,000. Now we want to find out what the rate is. So for option 1, it says that it's a simple interest-free savings account with Royal Bank of Canada. We know it's simple interest, which is why we're using the simple interest formula, and we're using 5% annually. So we're going to change the rate to 0.05. And it's over the course of 5 years. It just says up here that you want to invest it for 5 years. Make some interest over the next 5 years. Okay? So, this one's easy. You're just going to plug it in. FV equals 2,000. 1 plus 0.05 times time. So let's do that. 0.05 times should be 5. It's going to be 0.25 plus 1. So I'm going to have future value is equal to 2,000. And you can just honestly do this all in one step. I'm just showing it to you for the sake of clarity. Do whatever's in the bracket now first. Rate times 2,000 is going to give us $2,500. So if I wanted to know how much interest I'm making here, I equals PRT, or I could have just done, okay, I had $2,000 and I'm left with $2,500. I made $500 in interest here. Okay. So therefore, $500 in interest is made and $2,500 total. That's for our simple savings account. Let's go on to option 2. Option 2 here is our compounding tax-free interest savings account, right? And this is with TD Canada Trust, and it's compounded annually at 7%. Every year, they take the amount that you have, add 7% to it, reinvest it. So let's see. Principal is the same, right? Because this is compounding interest, you need to use a compounding interest formula, which is A equals P1 plus I to the power of N, right? P is going to be 2,000. Now we just need to find out what I and N are going to be. And if you go back and you look at the chart, it says that this is compounded annually. That means that the interest rate stays the same. So I is going to be 0.707. And the compounding period is just 1 times the number of years, which is 5 years. So in this situation, our N and our I is the same as our R and our T, right? So let's put that into the formula. So A equals 2,000, 1 plus 0.07 to the power of 5. A is equal to 2,000, 1 plus 0.07 to the power of 5. Sorry. Plus 1.07 to the power of 5, right? So 1.07 to the power of 5 is equal to 1.4026 times 2,000. A is equal to 2805.10. And that's my answer. So that means at the end, I will have 2,805.10 cents, which means that the interest that I earned here is going to be $805. And I do that by doing interest is equal to 2,805.10 minus the principal, which was 2,000, equals 805.10. Right? So I'm just going to write myself a therefore statement. Therefore, this person will make $805 in interest. And 2,805.10 in total. We can already tell that B is better than A. You're already making more money. Right? And then the last one here is option 3, which is saying, okay, I have a principal of $2,000, right? This tax-free savings account is with BMO, and they're saying they're going to compound me monthly at 7%, right? So if I'm going to go here, I'm going to say, okay, I still have a compounding interest. That's my first cue, so I should write down this formula. And then for compounding interest, I'm going to say, okay, I have if it's compounded monthly, I'm just going to go back and look at my original little table here. Oops, scrolled up too far. It's compounded monthly, which means that my I value is going to be the interest rate divided by 12, and my N value is going to be the number of years multiplied by 12, right? So let's go back down. So I is going to be the APR divided by 12, and N is going to be the number of years times 12, right? So let's do APR. Our annual interest rate is 0.07, divided by 12. Zero 0.07 divided by 12 is going to be 0.0058, right? Number of years is going to be 5 because it's over 5 years times 12. So that's going to be 60. So our n value is going to be 60. So I have my I have my n, and I have my p. So now I can find my a. So a is equal to 2000, which is my p-value, 1 plus 0.0058 to the power of 60, right? And to be frank, I'm just going to put this all into my calculator all in one step, and I'll show you how to do that. So let's see if I can pull up my Chrome here and our Desmos calculator. So I know I have, I'm just going to, pull this up. So 2001 plus 0.0058 to the power of 60. So let's do that. So 2000, and then I'm going to close bracket 1 plus, if you want, 1 plus 0.0058. And you can do this in your head if you want, like this part, to the power of 60. And my answer is going to be 2,829. And depending on what type of calculator you use, you might get 2035. I got 2035. I'm not sure what I did wrong here. So what I did for when I put it into my calculator, I just did it like this. I did the math first. And honestly, that might change your answer. So it might make sense to just do the math first. But it didn't in this case, so it's just 2000 times 1.0058 to the power of 60. Another way you could do it is you could do 1.0058 to the power of 60, right? And that gives you that number. And then you can multiply that by 2000 as well. So you can just say, oops, clear 2000 times answer times answer, right? And then you'll get the same amount. It doesn't matter which way you do it. Either way, you'll get the same amount. Okay? And depending on your calculator, honestly, just how accurate it is, you might get different numbers. So for the purposes of this course, I'll just go off of whatever this number is right now, which is 2829.618. 2829.618. So I'm going to put a 62, but on my calculator I got 2835.25, which both are right. It might just be the way that it calculates and the amount of decimal places that it's using that might throw it off, right? So that means that at the end of this I'll have $2,829.62, right? Which means that the amount of interest that I earned is going to be 2829.62 minus the original 2000 that I put in, right? Which means I'll have $829.62 in interest, right? So therefore, or this person earned $829.62 in interest for a total of 2,829.62. So the obvious choice out of all three of these is obviously the one that you make more money with. So option 3 is better because you make more money on your investment. So compounding interest is a little bit more complicated. The one thing I would really, really suggest is printing out this chart and keeping it for yourself. It's super helpful to just have them all at hand so that you don't have to do a lot of guesswork with I and N. It's just the calculations are already there for you, how to calculate them, right? You have this stuff for homework. So I posted a worksheet plus the textbook questions are already up as well. So check that out, go through them. Compounding interest is way more complicated than simple interest, but it's the one that more often than not is used in loans, especially in loans, because they want to take more money out of you. So it just makes sense, even if they give you a lower interest rate, sometimes they kind of trick you into having more of it. So if you don't pay off your loans right away, what happens is that this compounding interest, they're just reinvesting the same amount of money and you end up having a much larger sum to pay off at the end. Okay, we'll talk about how compounding loans are used or compounding interest is used in credit cards as well as student loans in our next couple of lessons as well. That is all for this lesson. Thank you. See you tomorrow.